Welcome everyone to our Mountain States Concrete Pipe Academy webinar for the month of September. This is the webinar about engineering ethics and liability. This will be given by myself, Jason Allen, and Heather Wadman, formerly Heather Christensen, who is now with Ogden City Engineering. We're going to jump right into it and introduce ourselves. So as many of you know, I'm Jason Allen. I have been for the last 5.5 years the Director of the Mountain States Concrete Pipe Association, graduate of University of Utah.
Hey Jason, are you sharing your screen or no?
I am. I should be. I guess I'm not. How about now? There we go. Every stinking.
There it is.
That's why I keep Heather around. That's why I ask her to help me out, because she keeps me honest here. So apologize for that. Yes, Jason Allen, that is me. I am a University of Utah graduate, had kind of a rough weekend, but I'm okay. For any of you who watched our Mountain States Monthly message and saw me and my son's predictions on how the game would go, we were all woefully incorrect, especially MacGyver, who thought Utah would win by 60. Boy, that was off. 19 years of experience in the engineering field, and recently took a job with Oldcastle Infrastructure. So we are looking for a new Mountain States director. So I'll talk about that a little bit more in a moment. I'll turn some time over to Heather to introduce herself.
Thanks, Jason. So yes, like Jason said, my name is Heather Wadman, formerly Heather Christensen. I changed jobs. I'm now with Ogden City. So Geneva is also looking for a new technical marketing manager, or TRE. I also went to the University of Utah. I have about 6 years of experience in the engineering field. A few of those years I got just through college while working at a research lab. Did some work in the wastewater lab, which was a lot of fun. Worked as a consulting engineering intern for several years, and then started at Geneva as their technical marketing manager and worked on their design team as well. And now here I am at Ogden City working in the public sector, so brand new stuff. I'm also thinking about dyeing my hair.
Boy, just new changes and a new start all over the place. So congratulations, Heather. I think this is a great fit for you, and I'm excited for you for this new chapter in your career and your life. And I appreciate you and your employers offering you to help us finish this presentation that we've had on the books here for a couple of months. So I appreciate you being willing to do that. So thank you, Heather, and congratulations. So as I mentioned, we are part of the Mountain States Concrete Pipe Association. This webinar is part of our academy, our Mountain States Concrete Pipe Academy. This is the 9th out of 12 academy webinars that we are doing. These webinars can always be found online on demand. You can watch any previous webinars, or this one, you can watch it later on demand. If you just go to our website, mountainstates.concretepipe.org, and click on the Academy website, you can sign up for those. As always, want to recognize our member companies, Geneva Pipe and Precast, who, as Heather mentioned, is looking for a new technical resource engineer. So if you're interested, please reach out to Geneva Pipe and Precast. Additionally, Oldcastle Infrastructure, that is the company that I currently work for now, and I started there a few weeks ago. And then we want to recognize Ashgrove and Wholesome. As I mentioned, we are looking for a new director for Mountain States. So if you would like to find out more information about that, we aren't looking for just any typical engineer. So you can go to notyourtypicalengineer.com for more information about that job. So just a few takeaways on today's webinar. We're going to jump into it real quick because we have a lot of information. I should also mention that we do have Jeff Peck is on the line, and he's gonna chime in only if we have anything. Jeff Peck with Oldcastle Infrastructure, only if we are violating anything of any import in regards to ethics. So he's our ethics watchdog today. The last time we gave this presentation a year ago, Heather, if you remember, we chose Randy to be our ethics watchdog, which I thought was kind of an interesting choice, to say the least. That we would choose Randy Wallen to be the ethics watchdog. But anyways, a much more astute choice is Jeff Peck.
Yeah, a far better choice, right?
So
where's my buzzer?
Yes. So today our takeaways, we're going to talk about ethics. We are going to talk about the industry code, and we're also going to talk a little bit about liability. So I'm going to turn the time over to Heather first so that she could talk about what is ethics.
All right. So when I think about ethics, essentially what is it, right? It's what you think about when it's right versus wrong, or good versus bad, but it's not always black and white, right? There were sometimes those gray areas because ethical principles may differ between person to person and family to family or country to country. What we think here in the United States is ethical might not be the same ethics system that they've got, in a different country. And it can even differ era to era. So thinking back maybe 100 or 200 years ago, when slavery was ethical or women in the workplace was unethical, me giving a presentation of this sort to a group of men probably wouldn't have been considered ethical. And so it makes you start thinking that, okay, ethics can change over time, change based on region. And so it's not always black and white. And then I always like to think about what ethics might change, in the next 15, 20, 100 years from now. What do we consider ethical or unethical right now that might be changing down the road? But it's not always black and white. There's definitely that gray area, but we're lucky as engineers because we have a code of ethics that we can abide by. And so let's talk quick about the definition of ethics, right? So what does that mean to you? So the Merriam-Webster dictionary defines ethics as the discipline dealing with what is good and bad. And we kind of already mentioned that. But then it goes on to say, and with moral duty and obligation, a set of moral principles, a theory or system of moral values, the principles of conduct governing an individual or group, a guiding philosophy, a consciousness of moral importance. Okay, so that's a pretty clear definition, but let's think about just the underlined portion here and think about that as it relates to engineers. So principles of conduct governing an individual or a group. And so if you think about engineers, our profession can be considered a group, and we're lucky to have a code of principles that we can kind of follow to guide us through our profession.
So I wanted to talk about a Gallup poll that was done in December of 2019. Now, Gallup does these polls every year, and interestingly enough, the one that they did in 2020, they only choose like the top 15 or 20 professions that they want to get an opinion on how people rate them with terms to ethics and honesty and ethical standards in these professions. When they did the 2021, they actually changed a few of these and put in new jobs and took out some. So we don't know how engineers ranked in 2020, but the last one that they did that had engineers was 2019. In 2019, the #1 highest rated ethical career choice was nurses, and engineers, if you notice, just edged out medical doctors. So medical doctors was or engineers was just ahead of medical doctors. I want to point out down here lower, we as engineers are considered more ethical than the clergy. And as we work our way down the list a little bit more, you have lawyers who, again, I'm still a little surprised they did that. And then we have down at the bottom here, members of Congress, if you notice, they are just ahead of car salesmen. So no offense, car salesmen, but members of Congress just eked you out this year. If you were wondering, in the 2020 poll, I just looked up that data yesterday, and Congress is at the very bottom. They are actually the lowest now. So we're going to start by doing I'm gonna lay out a situation here, and I want to we're gonna have a little poll after this. So I'm gonna lay this out and say, all right, an engineer. Okay, here's the situation. An engineer works for a firm that pays his expenses for a trade show. All right, and he wins a door prize that is worth $5,000. All right, they're worth $5,000. So the question is it ethical for the engineer to keep the door prize, or should he remit this prize to his employer? Now, keep in mind, the employer paid 100% of his salary, his travel, his hotel, his entry fee to the trade show. So the question is that ethical? So I'm going to launch a poll here, and we're going to see what the engineer should do. So go ahead and vote for that if you would like. You may have to exit out of full screen mode to do that. So all right, I'll give you a minute here to vote there. Looks like we've got almost all of you in there. So I'm going to close the poll here and share it with everyone. All right, so your choices are keep the prize, remit it to the employer, and about 40% of you said keep the prize. 56% said remit to prize to the employer, and 4% of you said run away to Albania and live like royalty. The average household income in Albania is about $80 a month. So yeah, you could live for quite a long time with that. So Heather, I apologize. I was having some technical difficulties there, and I think I accidentally muted you, but it sounds like you're back now.
You're good. Yeah, I'm here. And if you guys took this course last year, I think we hosted it around the same time. You should know these answers.
Mm-hmm. Yeah,
Certainly the answer is run away to Albania.
That's right. That is my favorite. That's what I would have done. What is the correct answer there? Well, the engineer has an ethical obligation to report the prize, and the ultimate decision is between the engineer and the employer. So this was kind of a black and white question, or a black and white answers to a gray area question. Depending on what the employer says, they can allow the engineer to keep the prize. They may say, no, you have to give it to us, but ultimately it's a decision between the two. So none of those answers were actually 100% correct, but we use this as an example to say, look, there is a little bit of gray area there. So you need to keep that in mind there. All right, so let's talk about the engineer's creed. Okay, the National Society of Professional Engineers has a creed. I have included this creed as a download, as a handout. If you click on the handout thing there, I've got two handouts there. You've got the Code of Ethics of Engineers that you can download, and there's the Engineer's Creed. And I would hope that you would take a look at this and read through it often. I'm going to read that to you here so that we can see what the thing. Oh, I got to close this and hide that. Sorry. We're going to move on here. So the as I mentioned, I have included this as a handout. You can download it. It's a PDF that you can look at. I'm going to read the Engineer's Creed to you. It says, as a professional engineer, I dedicate my professional knowledge and skill to the advancement and betterment of human welfare. I pledge to give the utmost of performance, to participate in none but honest enterprise, to live and work according to the laws of man and the highest standards of professional conduct, to place service before profit, the honor and standing of the profession before personal advantage, and the public welfare above all other considerations. In humility and with need for divine guidance, I make this pledge. This was adopted by the National Society of Professional Engineers in June of 1954. So that's been around for a while, and I absolutely love that creed. So feel free to download that, print it out, keep it in your office to remind you of why we have chosen this noble profession, and one that is considered to be of high ethical standards by the public. And I hope you read through that often there. So as part of the engineering ethics, there is also a preamble in the Code of Ethics here, and there's a couple of things that I wanted to highlight in that as well. One, exhibit the highest standards of honesty and integrity. Two, engineering has a direct and vital impact on quality of life. I was giving a presentation earlier today at the Salt Lake County to them, and they were talking about, in their training, they were talking about how when we talk about these first responders and these essential employees, we tend to think of doctors and nurses and your paramedics, your firefighters, your police officers, but they pointed out that oftentimes our public works departments, our engineers, they're forgotten in there, that we are also considered essential. Our role of bringing clean drinking water and keeping the roads clear so that people could travel to and from work, that is absolutely essential to making sure that we can maintain this way of life that we have. So it's very important there. Now, our service requires honesty, impartiality, fairness, equality, and we must be dedicated to the public health, safety, and welfare. So that's important to keep in mind there with our engineering code of ethics. Heather?
Yes. So there's also an additional code of ethics, if you have heard of them, ASCE, American Society of Civil Engineers. So what they've got is these canons, and they initially had 7 canons. They were adopted in 1914, but the most recent update in 2017, 18-ish, included an 8th canon. So we'll kind of go through these quickly because we're going to go through and break each one of these down, and likely you've already heard of them. So we'll spend a little bit of time on each one, make sure they're, well described. But real quick, canon 1 is hold safety paramount. Canon number 2 is service with competence. Canon 3 is issue true statements. Canon 4, act as a faithful agent. Canon 5, reputation by merit. 6, uphold professional honor. Canon 7, continue professional development. And the 8th canon, which is the one that they most recently added, is treat all persons fairly. So I'm really glad that they added that because I had no idea. Until 2018, I was treating everyone unfair. So that's nice to know that that's an ethical requirement of us as engineers. Good.
Yeah, I would hope that's not the only reason we're treating people fairly. Like, oh, now it's in the code of ethics. I guess I can't be a jerk anymore.
So let's break all those down. So moving on to the first canon, which is, again, it's hold safety paramount. So obviously safety is the first canon for a reason because it's probably the most fundamental of them all. The intent is that you're going to, in all designs, work to improve safety, health, and the welfare of the public, and that's going to be your first priority. Sustainability is one of the bullet points that's heavily emphasized in this canon because we want to create designs that are not only safe for us at a current time, but also for the future. We want them to be lasting for generations and generations to come. Safety concerns, anything that you might think as a concern as you're working on your design, you will need to be communicating that. So don't keep that to yourself. If you feel like there is a safety issue with a design or a project that you're working on, make sure you're bringing that up to your employer or to the client or to the owner of that project so that you can communicate through those issues before it comes to fruition. And the goal essentially of this canon is to improve the environment and quality of life in all designs. And so there is a case study on the next slide, which goes in to talk about why it's so important to keep safety first in your design. And of course, this is a pretty well-known bridge failure. It was the I-35W bridge out in Minnesota. The failure happened in 2007. The bridge was built in 1967. And so, or it completed construction. So the bridge was there for about 40 years before this happened. And on August 1st, 2007, at 6:01 p.m., the bridge collapsed. 13 people died and 145 people were injured. And so, Jason, I think you have an audio clip to play if you have it available.
Yep, I'll play that right now.
If you can turn it up a little or get it closer to the speaker, it's a little hard to hear.
And she said that the bridge was collapsed that she was on, and she had to go, and we can't get a hold of her anymore, and we're just trying to find out if she's okay or what's going on. But when they were crying, when we came down, they were just getting pulled out, and found out, is the person that I care about all right? I mean, are they hurt? I'd be happy just to know she's hurt right now, because that way I know she's alive. And
yeah, so things like that makes you really start understanding the importance of safety. Hearing someone's response about a family member that was on the bridge during the collapse, that's serious. So how did this happen? Was the bridge too old? Was that the issue? The bridge was 40 years old, and at that point in time, 1 in 5 bridges were older than that bridge. The service life of a bridge should far exceed 40 years. And, 20% of bridges at that time being older than that bridge, that was not the problem. No. But there were a number of reasons that could be pegged as the primary issue. When I dug into this project, this is, in my opinion, the primary issues in this bridge collapse was that there was some design errors. There was a lack of communication, and there was overloading. There was a construction project going on at that time where construction materials were being stored on the bridge in a critical zone, and all of these contributed to the collapse. And so let's take a little bit closer look at that story. So what happened is an investigation was undergone to basically perform a fatigue analysis on that bridge. And in that investigation, essentially what happened is they had to categorize that bridge as structurally deficient, meaning that it needs repair. And this bridge remained in that category, structurally deficient, for over 15 years. But repairs weren't made because essentially the bridge was stable. It wasn't continuing to go down in condition. So they were not repairing those bridges, or they weren't repairing the issues that were determined structurally deficient. However, the gusset plate, so for those of you who work on bridge designs, the gusset plate is essentially a big sheet of metal, which is used on the joints to transfer the load from member to member. And if you do bridge designs, you do know that the joints are essentially a critical zone in that bridge. So the gusset plates on this project, it was when they did this study of what happened, it was found out that the gusset plates were actually under designed throughout the entire bridge by a factor of about 2. They were essentially a ½ inch thick when they were supposed to be 1 inch thick. And so there you are, there's a design issue right off the bat. But as they went and did this fatigue analysis, they were realizing that the gusset plate, specifically one of the gusset plates, was starting to bend. The steel was starting to deform slightly, and steel, with the mechanical mechanisms of failure of different materials, we know that steel, when it starts to bend, it's giving us a warning, right? And so that is a big warning for us, and that should have been noted in the fatigue design that, hey, we need to be careful and we need to keep an eye on this and make sure that, you know, if no additional bendings occurring, and especially not additional loading. And then along comes some construction work where they essentially placed construction loads, major construction loads, over top of this, right in the same area of this bending gusset plate. So not only was the gusset plate beginning to fail, they also overloaded it in that same area. And the amount of load that they put on this bridge is outrageous. When they were going back and looking at it, they actually put 580,000 pounds of material over top of this bending gusset plate. And so if you're starting to think about just the sheer weight of that material on a bridge, a standard car, thinking maybe a Toyota Corolla, is about 2,000 pounds. And so 580,000 pounds would be equivalent to 290 Toyota Corollas. And this material was stored in an area that was 12 by 115 feet. And so if you think about the area, the footprint that a car takes up, you can maybe fit 7 Toyota Corollas in that area. And so 7, once you start realizing, okay, well then there was 290 Toyota Corolla, the weight equivalent of 290, you have to start stacking those cars, and you'd get 40 rows high before you got all of that weight there. And so construction loads are a really big thing that needs to be considered. And so the construction going on along with the design error and along with the fatigue analysis, those 3 items, along with the miscommunication between all parties, was the big error that happened with this bridge. But who had to pay for it? When we were talking about liability, who's at fault or who ends up paying? And of course, I want to bring it to your utmost attention that the people who lost their lives, the 13 people who died and the 145 people who were injured, were the ones who ultimately paid. But when we're talking about monetary value, the monetary liabilities fell on the design engineer and the fatigue analysis engineer, the firm that performed the fatigue analysis. And so the design engineer paid $9 million and the fatigue analysis engineer paid $52 million. But this just goes to show that, you know, these types of things can happen if we're not keeping safety, holding safety paramount in all of our designs and communicating and making sure that, you know, all things like this are being avoided. I think that was probably the biggest case study I could point out that was safety related.
I love it, Heather. There was a question that came in that I think is now is a good time to address it. The question is, this person would love to hear our thoughts on how to navigate difficult conversations when a project meets maybe the letter of the code, but also potentially poses a safety hazard. You know, that according to this canon number 1, we need to hold safety paramount. So obviously, if there's something that meets the letter of the code, the codes are meant and written, or ordinances or standards, you know, specifications. These things are meant to try to cover as many cases as possible, but they are left sometimes somewhat generic. And because of that, there may be some times where there is a safety concern on some of those. So we don't want to see that happen. We as engineers have an ethical responsibility to stand up for the safety. If it does pose a safety question, we need to reference this engineer canon that we have you know, taken it upon ourselves the responsibility to ensure that we are putting safety first. Just an anecdotal experience. Someone close to me worked at a municipality where someone who was not in the engineering department wanted them to approve a building permit that did not meet snow load requirements, and the building official and the engineer said, no, we're not going to approve this. It doesn't meet the snow loads. So hang on, I've got to mute Heather for a second there. I think I'm getting some feedback. So they said, we're not going to do that. But they went ahead and that person ended up losing their job because they said the safety is a concern here. And that's sometimes a difficult thing to decide. Do we want to lose our engineering license because we do something that is not safe, and make some concessions and use our engineering judgment and say, well, maybe we can do this or that. But you know, me personally, I would rather lose my job than lose my engineering license, because that's my way of making a living. And so that's what this canon is. And I would hope that any employer would be respectful enough to say, okay, I appreciate your opinion and your judgment there. But that's not always the case. But it is difficult. But you've got.
So Jason, that question.
Yeah.
Oh, sorry.
Go ahead.
So that question though that came through, are they asking what some good pointers are in order to handle those hard discussions that you might have to have with a client or your employer about potential safety hazards? Is that what that question was?
I think that's what it's asking is how do we navigate those? And my suggestion would be to, as you have this ASCE canons, the code of ethics, and I also included the National Society of Professional Engineers Code of Ethics for engineers to download as a handout. In there, it talks about the rules of practice, and it talks about how to do it. And I would cite those and say, look, I believe
That's great.
This poses a safety concern, and this is my own code of ethics. I cannot violate that. And I would hope that any employer would be respectful of that level of commitment.
Absolutely.
So, well, perfect. Let's move on to canon number 2. This is perform services only in your area of competence. Okay, this means that you'll undertake assignments only when qualified by education or experience, that you do not affix your signature or your seal to plans or documents where you lack competence. And then the question comes up, well, what if I'm the project manager? I've been a project manager on a handful of projects. I've been a PM where I had to sign and stamp the whole project documents. Well, that is allowed. You may seal and sign the entire project as long as you had technical engineers that signed their segments. So if there was an area that you needed, like a structural design, and from a structural engineer, I've had plans for UDOT where I signed the whole plan set, but we had a structural portion, 10 pages of that was structural. So I had our structural engineer sign those 10 pages, but I was able to sign it as a whole there. So that's where we're at on areas of expertise. I do have a case study that I do want to share with you about this. This is one that happened in 2014. This happened in Washington, D.C. This is a picture of that. This is a masonry sewer line. This was a 22-foot diameter masonry sewer line. In some spots, it got up to 22 feet diameter. That's a big old sewer line there. And if you think about all the sewage in Washington, D.C., and I'm not just talking about our congressmen and our elected officials there, but when we think about all the actual sewage in a big city, you have these huge pipes, and it's very important that they be protected and the structural integrity be protected there. In 2014, a 5-story residence was built directly on top of this trunk line, and there was only 2 feet of soil between the bottom of the basement of the structure and the top of this 22-foot masonry sewer line. Now, the building, the weight and the load of that building caused cracks in this sewer line and undermined the structural integrity of it. This entire design of this building, including the site plan, was signed by a structural engineer, not a site civil engineer. So they didn't do their due diligence. They didn't get utility engineers involved. They just had a structural engineer do it, and they signed and stamped outside of their area of expertise. In fact, the Washington, D.C. water and utility companies were not even notified about this until the project was complete. So the building is now in place, a 5-story building is now in place, and then the DC Water was notified that this building was built on top of one of their pipes. They went out and looked, and it was cracked and had undermined the structural integrity. So what happened? Well, the residents, the entire 5-story building was actually torn down as a result of that. Heather.
Sorry, I was muted. I didn't realize. Okay, so canon number 3. So issue public statements only in an objective and truthful manner. So essentially with this one, really it's pretty self-explanatory, right? You don't lie, don't mislead. Make sure that whatever statements you're giving as an engineer, you are being relied on in your profession to be able to cover what others might not understand. So in certain cases, a lot of times the public will build their perception based on what you say. And so if it's misleading, if it's untruthful, it can cause a lot of problems. And so there is an example of what can go wrong with implementing misleading public statements. And this one is probably one of the, in my mind, the more fun examples that we're doing today, because the rest of them are engineering failures, but the unsinkable Titanic. Right? Everyone knows the story about the Titanic. If you haven't seen the movie, go see it. I don't know how anyone has made it through life without seeing it yet. In fact, I knew we were doing this presentation, so I watched it a week or two ago. I love the movie, but essentially what happened with the Titanic? Titanic was the most beautiful and luxurious boat of her time. The design incorporated extreme safety factors, and so things like 16 watertight compartments that were going to help protect the ship from sinking. And with all of these safety factors being incorporated during the construction of the ship, a lot of agencies and even public magazines or well-known magazines like the Shipbuilder magazine actually were putting out public statements, and the Shipbuilder magazine stated that the ship was essentially unsinkable. And so with that, the perception of the public and even the crew members and the operators of the ship started to neglect safety in their protocols. And so they weren't doing the safety drills. They weren't giving instructions to passengers of the ship when they were entering. There weren't enough lifeboats, and there was overcrowding on the boat. And if you've seen the movie, they actually go into quite a bit of detail, but they had enough lifeboats for about half of the people on the ship. And in the movie, they even were neglecting warnings of icebergs. There was 6 warnings, but still they maintained their speed and their direction. And ultimately what happened is this ship took 3 years to build and 3 hours to sink. But with that's kind of the main purpose here, is that this well-known magazine, this Shipbuilder, put out a public statement stating essentially that that ship is unsinkable. And so that's what people believed, and that could happen the same with the engineering profession. If us as engineers are putting out engineering statements that are misleading or misguiding, bad things can happen.
That's absolutely right. So canon number 4, act for each employer as a client, act for each employer or client as faithful agents or trustees. Now, this means that we will disclose conflicts of interest. We don't receive compensation from more than one party for services on the same project unless it's fully disclosed. It means that engineers in public service won't participate in decisions with respect to services provided by them or for their firm. It means we won't solicit or contract from a governmental body on which principal officer of their organization serves as a member. So it's just, really that conflict of interest stuff. So I'm going to do a poll here. I'm going to lay this out, and then we'll do a poll. Okay. So we have Engineer A works for a state DOT and is an in-house project manager on a project. The contractor for the state project submits change order to Engineer A for approval, and Engineer A thinks that the change order is due to the contractor's faulty work and refuses to sign the change order. Now, I know this doesn't happen very often, but in rare occasions when a contractor doesn't get their way, this contractor contacts Engineer A's supervisor, who is not an engineer, just a manager, who directs Engineer A to sign off on the change order. All right, so the question is it ethical for Engineer A to sign off on the change order. Let's go ahead and launch that, and you can vote and let us know what you think. Is it ethical for engineer A to sign off on the change order? Yes, there's no issues here. Sign it and move on. Yes, it is ethical because the supervisor now assumes responsibility. No, he should demand that the supervisor sign it, or no, and he should report it to DOT authorities. Okay, I'll give you just another little bit here to vote. We'll take about maybe 10, 15 more seconds here. 2/3 of you have voted. We'll give you just a little bit more. We'll go 5 more seconds, so make sure you get your votes in. 4, 3, 2, 1, and we're closing and sharing. All right, let's share this here. So it looks like a majority of you said no, which is good. So yes, the supervisor assumes responsibility. A few of you said that, and keep in mind that the supervisor is not an engineer. And what is our engineers? Our ethical responsibility as engineers. So other answers: no, he should demand the supervisor sign it. Majority of you said that, and no, he should report it to DOT authority. So the correct answer is no, it would not be ethical. It should not be signed, and whether your supervisor tells you to or not. In fact, engineer A does have an obligation to report it to the state DOT authority. So if someone is pressuring them to sign something that goes against the engineering code of ethics, they do have a responsibility to report that. So that is the answer there. No, it is not ethical, and it should be reported. So the best answer in that one would be the last one, no, and report it to DOT authorities. Okay. Now, Heather, I have a question for you. Does an engineer have an obligation to save his or her client money in design? And if so, at what cost?
Ooh, well, so yeah, I think that all designs should be, I think that cost and economical consideration is part of sustainability. If we can't fund it, then it can't be sustainable and it can't really work, right? But
Agree.
Really, safety, and as long as we're going through part of all of these ethics and we're making sure the design is plausible and it's going to work, I think that, yeah, we should be saving our client money in our designs.
So as long as it doesn't violate some of the other safety ethical codes and things, and,
Right.
and Canon 1 of holding safety paramount, then we should be considering money, but it shouldn't be our top priority. Okay, I did a lot of work for developers when I first started in engineering, and they were a business. They were trying to make money. They were trying to do things as cost efficiently as possible. However, some developers were looking at this from a standpoint of, can we make these cutbacks do we really have to put this in? Do we really have to do this? And it got to a point where there were sometimes where I had a conversation with a developer where it was, I felt like it was putting the design in jeopardy, and it was no longer meeting the intent of the design there and what the city county had, and they were looking for technicalities to try to work around it to make maximum profit. So as an engineer, we have an ethical responsibility to share that and say, no, we cannot sacrifice safety and other ethics there. So Heather, I'll turn it over to you for canon number 5.
Absolutely, great. Okay, so canon 5, build professional reputation on the merit of their services and shall not compete unfairly with others. So what does this mean? Essentially, you should be building your reputation off of your qualifications. Do not falsify your qualifications. Don't misrepresent your qualifications, including brochures and presentations that are built from your firm and including your firm's qualifications and your associates' qualifications. Do not offer, give, solicit, receive, indirectly or directly, any contribution to influence award of a contract. And there's a pretty good example of how this ethic code could be abused with the story of Vice President Spiro Agnew of the Nixon administration. And so Spiro Agnew was the vice president in the late 1960s, early 1970s. And we had a video for this, but The video was a little bit long. I think, Jason, you're going to plan on sending that out so people can do a little bit further investigation on what happened here if they weren't aware of the story. But essentially what happened is where Spiro Agnew was an elected official out in Maryland, he began as, I believe, the mayor. And what was happening is firms within that area that were working well in the private sector were noticing that they weren't getting jobs in the public sector. And they weren't really sure what was going wrong. They were submitting their, proposals for all of their requirements, but they just weren't getting the work. And so whispers came around that essentially 5% of the fees of the engineering design fees are supposed to be kicked back to an elected official in order to start getting that public work. And they started, that was just the norm in that area out in Baltimore County. And Spiro Agnew was one of those elected officials that was collecting money from engineers and allowing them to get work specifically by paying some of their fees. But he wasn't the only one. There were other elected officials, and there was actually 7 engineers that came from different firms that came and testified against these elected officials at one point. And these engineers, funny be it, because they were basically stating, yeah, we've been kicking back 5% of our money to get this work. They testified against this issue, and all of them lost their licenses. They lost their ownership in their companies. They lost their ability to continue engineering after this. And Spiro Agnew later resigned. So, I mean, it's crazy that this could get, it's outrageous in my mind that this could go up so high. As you'd think that Spiro Agnew, once he became vice president, at least he would be like, well, this is a little much, but no, he continued accepting the money. And he resigned and engineers lost their jobs, and it was a big deal.
That is absolutely crazy that it went up that high, but if we learned anything from Congress in the last few years, that nothing with our elected officials should surprise us. So
what was that slide where it was talking about the accountability of, or the ability of people to trust different professions? Where did politicians end up on that?
Yep. Yeah, they were very low, and in 2020 they were actually the lowest. They were under car salespeople. So in 2019 they were just above, and in 2020 we were below. The elected officials were below. Go. So canon number 6 is conduct themselves honorably, responsibly, ethically, and lawfully to enhance the honor, reputation, and usefulness of the profession. Heather just mentioned the reputation and how we're viewed in the Gallup poll. Reputation is a very important thing. In fact, Reputation is also my favorite Taylor Swift album. I absolutely love Taylor Swift and that album. So you gotta play some. Ooh, yeah, Reputation. Now you heard about me. Ooh, right. Love Taylor Swift. Gotta love it. I also have a hobby of recreating my favorite album covers. So this is me recreating my favorite Reputation album cover of Taylor Swift. So I just wanted to share that with you. But reputation is very, very important. That the Canon 6 of the ASCE code also states that engineers shall act in a manner as to uphold and enhance the honor, integrity, dignity of the engineering profession, and shall act with zero tolerance for bribery, fraud, and corruption. Okay, so
wait, Jason, go back to those photos. Which one was Taylor Swift?
Taylor is actually the one on the left. I know that's hard to know. I'm actually on your right. Believe it or not. I
double checked. Okay, now, yeah, I'm seeing it now.
You see it now?
Yeah.
Okay, just making sure. Yeah. Okay, so I'm gonna lay out a little scenario here, and then Heather, I'm gonna ask you to answer this one. So this is just a case study here for a DBE, or a disenfranchised business entity. All right, so engineering firm funds an employee to establish a DBE company under his name to bid as a subcontractor on state projects. So for those who don't know, DBE is a disenfranchised business entity. So if it's a company that's owned by a minority, including like female-owned businesses or other minorities. So the engineering firm would do the work and then pay the DBE a fixed fee. So my question is it ethical under the Code of Ethics to do this? What do you think, Heather?
Ooh, I'm gonna have to take a wild shot in the dark here and say probably not.
That is correct. It would violate Canon number 6, this is exactly what we just talked about. Act with zero tolerance for bribery, fraud, and corruption. That is fraud and corruption there, to have a kind of a shell company that wins the work because they're a DBE, and then one company does all the work and then kicks back. It's almost, you know, it's not quite as egregious as what was done with the Spiro Agnew, and it didn't reach up as high, but it is every bit as much fraud and corruption. So that should be avoided. So yes, good job, Heather. Okay, let's turn it over to you for Canon number 7.
All right, Canon 7. So continuing professional development. Hey, that's what we are doing right now. Well, all of you that are attending this presentation, you're continuing your professional development. And that is part of the fundamental canons of ethics. And so what does that mean? Essentially, we should be updating our knowledge, continuing to learn, and knowing that design standards and practices might change over time to make sure that we're up to speed and up to date on all the most recent standard adjustments. And not only is this paramount for yourself, but especially to those around you, so that you're working with, especially if they were maybe working under you, that you give them opportunity to continue their professional development as well and make sure that they're keeping up to speed on requirements. So let's talk about requirements of professional development. Utah has some requirements. So PEs in Utah require 30 professional development hours every 2 years, so 15 a year, but we do not have to take an ethics course here in Utah. The other states around the country, there's 16 states that do require ethics PDHs. New Mexico is the only state in the Western US that does require the ethics PDH. Nevada requires an ethics exam for licensure, and so does California, because I actually had to just submit my application there. But funny be it is that California does not require PDH credits at all. They just require their ethics exam at the beginning. So hopefully their engineers are staying up to speed on all the latest requirements.
Interesting, I didn't realize that. Very cool. Well, we'll move on to Canon number 8. Canon number 8, as Heather mentioned, this is a new canon. This was adopted in July of 2017. So, you know, only a few short years ago. Engineers shall, in all matters related to their profession, treat all persons fairly and encourage equitable participation. And so this is without regard to gender or gender identity, race, national origin, ethnicity, religion, age, sexual orientation, disability, political affiliation, or family, marital, or economic status. So we will not discriminate against those people. So as Heather mentioned, the importance in Canon 7 when it talks about continuing education, if we hadn't done any continuing education, if we weren't learning and constantly learning, maybe you wouldn't know about this fundamental canon number 8, and maybe you would still be mean to people. I mean,
yeah.
So now
it's easy to
you have an
mean.
ethical
It's hard to be
responsibility
nice.
to be nice.
Yeah.
All right, let's move on now to let's do a case study here, right? Let's do another one, and then we're gonna have I'm gonna lay this out, and then we're gonna ask the question here to you on who owns the work here. We're gonna do another little poll here. All right. So the question is, who owns the work product? All right. Engineer A is an employee of firm X. Okay. This engineer maintains copies of everything that they have signed and sealed for their personal records for personal and professional liability. They leave the firm, and firm X demands the copies that they have, claiming they're the property of the firm. Engineer A refuses, claiming that they have the right to copies of their work. Now, was it ethical for engineer A to refuse to return these copies? Now, I'm going to go ahead and launch this poll. I want to know what the audience thinks here. Who owns the work? All right, I'm going to launch that. The options are the engineer, the engineering firm, the client, or nobody. It belongs to all of us collectively, dude. Who owns the work? We'll give you about a minute here to put in here and see. All right, we'll go about 20 more seconds here. Alrighty. Most of us have voted here. About 5 seconds. 2, hurry and get it in. 1, I'm gonna close and share. All right. Okay. Some said the engineer. About half of you said engineering firm. A little bit over a third said the client. And it looks like we have a couple of communists in the crowd there. Nobody, it belongs to all of us collectively, dude. So way to go communists. So the question of who owns the work, well, is it unethical to withhold that and not give it back? The answer is yes, it would be unethical. Now, ideally, this would have been discussed and negotiated when they first started at the company, and some companies do have these clauses in their employment contracts or different things on who owns the work, if it's intellectual property, who owns it, if it was things developed by their. The engineer does have a legitimate interest in the work that they sealed and signed, but Firm X also has proprietary rights because they were paid. They were hired by that company to do that work, and so that should be respected by Engineer A. My hope would be that they would first discuss and negotiate this in the terms of their departure and come to an agreement. But yes, to withhold all of that work after they were paid by the company to do that, that would be considered unethical. So real quick, we'll move into some definitions that is critical to know. I'm going to go through these relatively quickly because we do have a final case study that I want to spend adequate time on. So let me get back to our presentation. And let's talk about definitions. Okay, these definitions are duty, standard of care, negligence, and liability, because it would be remiss if we talked about ethics without discussing what our liability is and what we should know. So duty is a legal obligation that entails mandatory conduct or performance to render services or perform certain acts. The standard of care means that you will perform as others would reasonably do in the same circumstances. Okay, negligence is failure to do what is reasonably required. But we're going to focus here for the next little bit on liability. Okay, liability is a condition of being responsible for a possible or actual loss, penalty, expense, or burden. And we have a really fascinating case study that we want to talk about. And Heather, I'm going to turn it over to you to start discussing about this.
Great, thank you. Okay, so this is a fish hatchery out in Jasper, Texas, and this is actually a pretty big project. You might not be able to tell just from the quick sketch that's up on the slide here, but it was a $27 million job. Construction began in 2008, and there was quite a bit of pipe on this project, so 11,000 feet of pipe roughly, and they had used a flexible pipe material. And this pipe ranged in diameter anywhere from 30-inch up to 60-inch. So it had 30-inch, 48-inch, and 60-inch diameter pipe. And if you're thinking about this type of a project, it's a fish hatchery, you know there's water involved. You know that there's going to be, you know, infrastructure underground that they'll need to ensure is installed properly. But with groundwater involved, it might impact soil properties. And so that might be something that you should definitely be paying attention to in the design, right? And so the trouble with underground infrastructure is it can often be overlooked. It's that out of sight, out of mind scenario. So let's talk a little bit about what happened in this project, and something that went wrong should have been put in the presentation. But essentially what happened is, as this project was about 30% complete, they started noticing some failures in the pipe. And a forensic investigation was ordered, which found excessive deflection. So in these photos, you can see the pipe was deflecting quite a bit. There were some collapsing errors. And from there, we'll talk a little bit about what was going on in the design and why this was happening in the design. But essentially, they used fill height tables. And so if you guys are familiar with fill height tables, they're a great tool to use for standard designs, but there's a list of parameters that what they design these fill height tables to meet. And typically it's one constrict soil properties, right? So maybe it's 130 pounds per cubic foot of soil and this type of soil materials and no groundwater. They typically don't assume groundwater. And so with this design, they likely should have been considering doing a full design on that pipe rather than just using fill height tables, which are pretty standard use. Geotechnical studies. So geotechnical studies are a pretty small part of the project, but they make a huge impact when we're talking underground infrastructure. Geotechnical studies were kind of left out of this project. And so it became really evident after they started noticing those pipe failures, and then groundwater being such a big issue. With groundwater, it's going to impact your soil properties, and you've got to consider the different loading on the pipe that happens with groundwater. There's going to be water weight and buoyancy loads and things like that that need to be considered in that design phase. And last but not least is installation specifications. So this one's bolded and underlined because with this project, what happened is they were initially considering to do a rigid pipe material. And so they had built the project specs around that rigid pipe material. And when they went out to bid, they had decided, okay, well, you know what, we'll just make this a bit cheaper and go with a flexible pipe material. Fine and dandy, but the specifications need to reflect that new material choice. And that was what the big issue was, is that they were utilizing these specifications based on the rigid pipe material, but then they switched it to flexible pipe. So those are kind of the design issues of what happened with this failure. But let's talk installation issues. Compaction. Compaction is a big thing. So with rigid pipe, essentially you can get away with compacting quite a bit less because the concrete pipe, the structure is, the pipe is generally designed to handle most of the loading on that job. Whereas flexible pipe materials, typically with that, the structure has to be built on the project site, meaning compaction is a critical requirement of the installation. And so compaction, if they were doing it per rigid pipe, but it's a flexible material, it's not going to be sufficient. The trench box. So here's another thing, is that with the trench box, what's happening is when they did the compaction and then they moved the trench box down, they were actually creating a void in the soils that had just been compacted, which then, of course, loosen and become even lesser compacted. And so moving that trench box as they were installing became a big issue as well. And groundwater, compacting saturated soils is not the easiest task. And with high groundwater in that area and no dewatering happening, it was a big issue. And last but not least, again, bolded and underlined, is communication between all parties. Communicating what the design is intended to do and what materials are intended to be used is a big aspect of this type of project, right? So communication is a key part of every project, and utilizing avenues of communication can greatly reduce the chances for error.
Absolutely. So Matt Williams of the Outdoor News in September 30th, 2009 said, another unknown is who's going to foot the bill to pay for the glitch. Both the construction company that installed the pipe and the engineering company that designed the project are saying they did everything right, but it is real obvious something went wrong here. It could be that multiple parties have some culpability here. We'll just have to wait and see. I'm going to launch our last poll, and then we're going to wrap things up here after we tell you who was responsible for this. But I'm going to launch this and allow you to choose who was responsible for the $3.3 million fix. Would it be the manufacturer of the pipe, the design engineer, the contractor that installed it, or the public agency and owner that took over the pipe? Who is responsible for it? Okay, we'll give you just about 1 minute here to vote, and then we'll wrap everything up in a nice little bow for you. Okay, we'll give you about 15 more seconds, so hurry and get your votes in. Okay, I'll give you 10 more seconds. All right, and we'll share it here. All right, a majority say the design engineer, about half of you, 40% contractor, 10% manufacturer, none said the public agency or owner. Great job there. Now let me let's go ahead and expose the answer here. Based on this report, the design firm bears the brunt of the repair bill on the fish hatchery there. Now, of that, when I say when it says the brunt of the $3.3 million, the design firm was ordered to pay $3.2 million of that, and the contractor paid $100,000 of that. So it was the design firm. What happened was, as Heather mentioned, it wasn't clearly communicated in the specifications. It was originally designed for concrete pipe, where the engineer called out the specifications. The manufacturer was using those same specifications, and then they sent it on to the installer with those specifications. And so that's how it was designed. That's what the design firm did. Unfortunately, when they allowed flexible pipe to be used, the engineer did not update the design. And in the engineer calls out in the plans per manufacturer's recommendations. When we do that with concrete pipe, the manufacturer recommendations are clear with these ASTMs. Okay, what happens is it goes over to the manufacturer, then references ASTM D2321, and ASTM D2321 references what the engineer's responsibilities are 29 times, including updating fill height charts, taking account for groundwater, side fills, compaction, all of that. All those responsibilities are of the engineer, which then goes back to the engineer, which says as per manufacturer's recommendation, and we start this whole vicious cycle all over again. And so it is the engineer's responsibility to limit their liability to ensure that when they design and there's a change, that it is communicated clearly and the designs are updated, because in this case, that did not happen. And so that's why the design engineer was responsible to pay the most. So Heather, if you want to summarize our takeaways here.
Absolutely. So essentially what we had wanted you to take away from this presentation is to understand ethics, right? We wanted you to understand ethics. We want you to realize about liability as it relates to ethical choices and industry code. Those are the takeaways, right? Did I get the takeaways right?
That is correct.
Yeah.
Ethics, industry code, and liability.
You weren't populating on the slide. I'm like, what did we take away from this?
I apologize. I want to see if you can remember what we had just talked about for the last time. We want to thank everyone for being part of this presentation and taking part. We had some questions come through and then we answered those, but if there are any other questions, we'd be happy to answer those now. I am going to put up on the screen some content information. About 1/3 of this content information is still accurate and correct. So I apologize. This is the one in my haste, Heather. This is the one I forgot to update. So I didn't even get your name right there.
That's all right.
My phone number and my email address are still active. You could contact. Yeah, I don't even know who Heather Christensen is. It's Heather Wadman now.
That person doesn't exist anymore.
But if you do have any questions for us, please let us know. If you have one specifically for Heather, feel free to reach out to me and I will put you in contact with her with our updated contact information. Hopefully most of you received an email yesterday giving you some updated contact information, but that's all I have. It doesn't look like there's any questions coming in. So it looks like we addressed and answered everything that people wanted to hear about. So thank you again, Heather, for taking your time out today and helping me with this presentation. It's always great to co-present with you. And once again, we wish you the best of luck in your new endeavor at Ogden City. Congratulations and best of luck.
Thank you. Yeah, thank you so much. Thanks everyone for your time.
Hey,
Great job, you two.
And thank you, Jeff, for being on the line. I noticed that the buzzer didn't go off, Jeff, so I guess we were ethically in line the whole time.
We did pretty good.
Okay, perfect.
No
Well,
foul play.
thank you again, everybody. If you do want to watch any of our past presentations, go to mountainstates.concretepipe.org/academy to sign up for any of those on demand. This will be uploaded later this evening for on our website so that you can look for that so that you can watch it on demand between now and the end of the year. So we appreciate you taking the time and sharing it with us today, and we hope to see you again soon.
See y'all later. Bye-bye.